AP Stats, welcome. Chapter 6 review here. Sorry the video has not been postponed way too long. As I mentioned in the class, I was not really personally able to do this during my vacation. So I'm going to just do this for you guys now. Hopefully you guys have already answered the survey at this point, where if you guys want to decide to take it tomorrow or Thursday, it's totally up to you. So after this video, just try to get the sense of how you feel and then make your decision then. There's no problem whatsoever if you decide to do that. Some of these questions we've actually done in class. For those, I'm going to go over that a little bit briefly compared to most. Most of the questions should be coming from FRQs and beyond when we did the geometric random variables, which was the toughest point. Number one, which of the following data is not continuous? So we talked about discrete, and then we also talked about continuous. Usually continuous is where it's pretty much time. Every values themselves are not like integers. So discrete are usually just integers where it's like points, dice, and 1, 2, 3, 4, 5 kind of thing. Where continuous is kind of like from 1 to 2, like everything in between and beyond and things like that. So the gasoline in the car, now it's not just 1, 2, 3 gallons. You could have 1.1 gallon, you can have 2.2, like, anything in between these is a fair game. So that's not going to be not a continuous, it is a continuous, data set. The time that it takes to commute in a car, any time, please assume it's going to be continuous time. Number of goals scored by a hockey team is going to be the correct answer, because that can only be 1, 2, 3, 4, 5. You can't score 1.1 in a game. It's either one goal, 2 goals, and things like that. Distance also 27.2 miles. So anything with a decimals, it really means that it can be continuous. So hours, again, you can have hours of life expectancy. It can be like, 1.5 hours and things like that. So that's going to be continuous also. So the correct answer here would be C. Number 2 has 2 calculus classes, average 78 with 83, and the standard deviation 69. What is a new standard deviation? Remember, combined variables in 6.2 tells us that the new standard deviation is, the formula would be the standard deviation squared plus the standard deviation squared of those respective x and y, square root them, and you get the answer. So that would be 36 plus 81 in total. So that would be square root of, what is that, 117. So I'm going to pull up my calculator here. Let's see. So with the calculator, what I'm going to do is I'm going to just do square root of 117. And then so it just gives me 10.8. So I'm just going to pick that as my answer and just move on. All right. So the next one. So number 3, 2x plus y, it says. Now let's just talk about the mean first of all. The mean will always be just according to it. When we do 2x plus y, we were just simply going to add those 2 things up here. So if I multiply the first mean by 2, I'm going to do 2 times 6. And then the mean of y, it just simply stays as 8. So it's 12 plus 8, which is 20. So the mean has to be 20 here, which means it's going to be C, D, or E. Amongst those choices, I have the standard deviations, of course, of 0.5 and 0.6. Now, if you take a look at the formula, which is this. Now, the standard deviation has been multiplied by 2. That impacts your standard deviation for x, which means the 0.5 actually has to turn into a 1.0 because you have to double the 0.5. So it's like 2 times that. And then you have to add the y standard deviations to it. So it's 1 plus 0.36, and you have to square root that. So therefore, if you do square root of 1.36, you get 1.166, so it should be E for number 3 here. Number 4, we have a marketing survey. I believe we did this question. What is the probability that randoms that the household has at least 2 cars? At least 2 cars means 2 or more. So you just have to add all of those probabilities up there. So that would give me 0.39 as my final answer. Number 5, what is the probability using number 4 was the expected value of the cards in a randomly selected household? So for expected value, you just have to put all these numbers into the list and then find out what the mean is. For me, I'm just simply going to use the formula here just to show you guys. So I'm going to erase all of this first. So I have 1 times 0.37. We don't really care about the first one because it's going to give me 0 anyways, plus 2 times 0.2, plus 3 times 0.11, plus 4 times 0.05, plus 5 times 0.03. So 0.37 plus 0.4 plus 0.33 plus 0.20 plus 0.15. Once I add all of this up, I should be able to get the expected value. I think, what is that going to be here? So that's 1.10, 1.30, 1.45. I believe that the correct answer here should be C. Number 6, a dealer in Las Vegas selects 10 cards from a standard deck of 52 cards. So why be the number of diamonds in the 10 cards selected? So 52 cards, so you're selecting 10, it's fixed. So I know that this is going to be a binomial situation. So I'm going to select from A, B, and C here. With the observational probability of success of 0.25 with n is equal to 10. The only problem here is that the percentage, the probability bins, to keep them to be the same probability, your card has to be replaced. Provided that the selecting card is replaced in the deck, that is the key thing to note here. Because if you select a card, but you don't put it back, now you're selecting out of 51 cards, out of 50 cards, so your probabilities will change, which means it's no longer going to be a binomial situation. So in order to keep that same probability checked for S, you must have a same probability by putting the card back. Number 7, I believe that this is just a calculator problem. So go to your stat list. I'm going to just put all of this in. And the probability respectively. All right, so now with that, I'm going to do stats, calc, one variable stats, and the frequency list with list 2. And so it gives me all of these things. Standard deviation, it seems to me it's 1.32 from that answer right there. So that's just a simple calculator question. Number 8, random variable, the value of constant C here. Well, all of this has to add up to a 1. This gives me 0.1, which means this has to give me 0.9. So 4C plus 2C has to give me 90% because the rest of this place is 10% here. 6 equals 0.9, C equals 0.9 divided by 6. So the value of C should simply be that. What is 9.9 out of 6 here? I can't do math. So I'm just going to rely on my calculators, 0.15. The variance of the sum of the two random variables x and y is simply going to be this. Oh, I'm sorry. It's going to be this because the condition has to be stated as well. X and y must be independent in order for that to happen. We're talking about variance, so which means, you know, you have to square the standard deviation. But if I want to find out the standard deviation, I will just have to take that and square root that, right? So 9 should be D for that matter. Number 10, it is known that about 90% of widgets made by Buckley Industries meet specifications. Every hour, a sample of 18 widgets is picked that meet the specification. What is the approximate mean of the standard deviation of the number of widgets meeting specification? So in these particular cases, you have to pretty much assume that the percentage and the number of the widgets is picked. The formulas for those is that the mean is NP and the standard deviation is square root of NP times 1 minus P. If and only if you can assume the fact that this is going to be independent and all that stuff. So there is this 10% rule that we need to pick for. So 10% rule states that any number of the population, if your sample size is, let's say, small enough, in such a way that it's less than 10% of the total population, then you can pretty much assume that it's going to be independent. So this is to check for independence. I'm assuming that in industries, they make probably more than 18 widgets or 180 widgets for that matter. Therefore, I am allowed to use this formula. So I'm going to just simply put 90% of 18, which should give you about 16.2, I believe. Yes. So I'm going to eliminate A and B. For the standard deviation, it should be 16.2 times the probability of failure, and you have to square root that. So it's the square root of 1.62. And so you get 1.27, which should be D, and 10 is indeed D for that final answer. Number 11, the expected profit. So expected values, again, you just have to take a look at these, multiply, add them up. So that's 500 times 0.05 plus 1,000 times 0.13 plus 2,000 times 0.22. And then it says that it sells the tickets for $10. So make sure that you subtract $10 at the end because that's how much that they're paying. This is the expected payoff by playing the game. So let's just use the calculator for this. I don't really feel like, 0.05 plus, what is it? 1,000 times 0.13 plus 2,000 times 0.22. All right, so that's the expected value. And you subtract the 10 from it because you expected to pay that much out of your pocket. So your expected value is 585 for that matter. Let the random variable x represent the number of money Carl makes by tutoring statistics during summer. X in normal, mean, standard deviation. Awesome. The probability of approximately 6.6. That in randomness of the summer, Carl will make less than about. Okay, so we are talking about this, where I am talking about the value x, and this is 0.6. Assuming x is normal means I can just do normal, PDF, CDF, or inverse norm for that matter, yes? So let's bring out the calculator. Let's do second varies. And then I believe we're doing inverse norm. Area is 0.6. Mean is 240 with a standard deviation of 60. And for me, the tail is always going to be from the left-hand side because it's making less than about, so we're starting from the left until that value. So we're expected to make about 255 or less, and that should constitute about 60% of the entire data here. And 12 is indeed C for that matter. Number 13, free response questions. We've done this in class, but I'll do this briefly. Remember, the probability has to add up to a 1. So that should be 0.1 for this, 0.6, 0.9, and 0.1 is the leftover. Find the probability the paying score is less than 3 means these two. Just to give you a little bit of a notation, this is probability of x equals to 5. To find the mean for the distribution and to find the variance and standard deviation, all those lovely things, we're never going to find out the standard deviations by hand. So I'm just going to clear this list, clear that list, and start from scratch. 1, 2, 3, 4, 5, and then 0.1, 0.2, 0.3. Oh, that's my fault. 0.3, 0.3, and then 0.1 for that. Stat, calc, one variable stats, and then bam. So we do mean of 3.1, standard deviation of 1.13. And so you take that number, 1357, square that, get variation of 1.289. So all these lovely things, I believe, let me just verify my answer real quick. Yep, they're all making sense. Suppose the pain scores for 2 randomly patients are recorded. Let y be the random variable representing the sum of the 2 scores. So I'm on part F, by the way. I know the font is really small. So if I'm talking about the sum of these 2 test scores, find the mean of y, it says. That's just simply taking this and adding the 2 means up. Remember that the mean of x plus y is mean of x plus mean of y separately. 3.1 plus 3.1, which equals 6.2. Now for the standard deviation with 1.13, you're going to do 1.13 squared plus 1.13 squared, and you just have to square root that. So then what I'm going to do is 1.13 squared plus 1.13 squared, square root of that value. And then you get 1.59 as your standard deviation. The answer key says 1.60, but it's pretty much the same deal. I cut up all the values from the like 100th place and onward, so that probably is the difference, but you close enough to pass for it. Number 14, number 14, if a player rolls 2 dice and gets a sum of 2 or 12. See, every single time when they're talking about a sum of rolling 2 things, you really want to draw yourself a table for this and figure out just how much is the probability of you getting a 2 or 12. So 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. That's your roll for the first. You can either get an outcome from 1 through 6, get an outcome from 1 through 6. And I know this is tedious and annoying, but I'm going to have to write down the sum of all of these guys. Yes, you heard me correctly. 2, 3, 3, 4, 4, 4, 5, 5, 5, 5. If you're wondering what I'm doing, I'm just simply taking 1 and 1 and adding it. 1 plus 1. 1 plus 2 is 3. 1 plus 3 is 4, and so on. And I'm filling in all the blanks. Yes, please trust me when I say that there is a purpose to this. So 6, 6, 6, 6, 6, 7, 7, 7, 7, 7, 7, 8, 8, 8, 8, 8, 9, 9, 9, 9, 10, 10, 10, 11, 11, and 12. Okay, so now I have all these values, and so I am going to take a look at just what's the probability of you getting 2 or 12. So 2 or 12 happens twice out of total number possibility of 36. So that is your probability of you getting a 2 or a 12, and the value of that is $20. Remember, the expected value is always n times p, the value times the probability. The value times the probability. Therefore, the expected value of that particular event happening would be 20 times 2 over 36. Plus, you win $5 when you have a 7, but 7 occurs 6 times, I believe. So that's 6 out of 36. And plus the remainder you just win nothing, $0. And the probability of that happening is, I believe, 28 out of 36. That literally means all of these other numbers that hasn't been called. All the numbers that's not a 7, 2, or 12, that's 28 numbers in total. So when you actually do this on a calculator, let's say, you're going to go 20 times 2 out of 36, 5 times 6 out of 36, plus this answer. So I get 1.94 as my final value. That's 0, so I don't really have to worry about that. So your expected value is that you get about $1.94 every single time you play this game. But look at how much it costs you. It costs you $3 to play this game. So you actually have to subtract the $3 because that's going out of your pocket. So your actual profit is negative 1.06. So expected value of this is negative 1.06, which means you can expect to lose $1.06 every time when you play this game. Here's the probability distribution function for a continuous random variable. So remember a normal distribution curve, and the percentages of anything that's happening is under the curve, like area under the curve, if you will. So here they give you these little nice boxes in this grids, and you just want to find out the probability. So that this is defines a legitimate probability density function. Any probability density function, all the probabilities under the curve must equal 1. So what that means is this area that I'm shading for you in red, that actually needs to add up to a 1 in order for it to be a legitimate density function. So how do I figure out the area of all of these guys? Well, think about what constitutes this little square right here. In horizontal distance, it values 1. And in vertical distance, that's a chance of happening, which is 0.1. It's basically finding expected value of this entire thing. So this little red box represents 0.1 in terms of expected value. If you literally count them, that's 1, 2, 3, 4, 5, 6, 7, 8, and 9 for the very first one. That adds up to about 0.9 in total. Now we have this little triangle here. If you really think about this part and this part, and if you're wondering about whether that's going to be exactly fitting in half, to answer your question bluntly, yes, exactly. But, you know, take this triangle, for example, and try to use geometry to try to solve for this. The distance, horizontal distance is, I'm sorry, that's not a 3, that's a 1. And the vertical distance is 0.2, right? Because it goes twice. The area formula for the triangle, 1/2 base times height, something from geometry I wish you guys remember, something you guys learned earlier, way back 2 years ago, approximately, maybe 3 years ago. 0.2, 1, and then that should give you that's 0.1 in total. So I'll just erase this and make sure my handwriting is much better. So 0.1 and 0.9, when you put them all together, that's 1. So yes, it's legit because it adds up to 100%. Now define the following probabilities between 0 to 3. Okay, so between 0 to 3, what does that mean? It means that you're going from here all the way to here. So finding the area of that. Let's count the actual like squares. 1, 2, 3, 4, 5, 6, 7. And we all know that triangle is equal to 0.1. So that's 0.8 in total when you add them all up. Between 2 and 3, well, that is simply where the 2 starts and 3. And so we are going to do this. So how many boxes do I have? 1, 2, 3, 4, and the triangle, which makes it 0.1. So that should be 0.5 in total. Okay. Oh, so let's see. So it seems like for part C, I believe that I made a little mistake here. Point to find the area under the curve from 2 to 3. It says, oh, from 2 to 3, I believe that you're supposed to find out the area between here to there, which means that, so 2 ends here, 0 ends, 1 ends. So they probably should have labeled this a little bit better because I can't read this. That's 1, that's 2, and that's 3. So between 2 and 3, it should be labeled like that. So we're really looking at this one box in this triangle. So that should be 0.2 instead. That's my apologies there, guys. All right, number 16. A manufacturer produces a large number of toasters. Is it a binomial setting? Let's check. Bins, we have 20. Same probability of defectiveness, independence. Can we assume that each toasters are going to be independent from one another? In order to prove this, guys, you guys can just do the 10% rule, where n is less than 10% of n. As long as that's happening, we can assume independence. Is 20 less than 10% of all the toasters in the, that's being manufactured here? Yes, I can assume that to be the case, so it's independent. Bins, it's binary because we have defective versus non-defective. So yes, this is absolutely binary situation. Define the probability that exactly one of the toaster is defective, which means we are really doing that formula 21, 0.02 to 1 power, 0.98 to the 19th power if you use the formula. Or we can be smart about this and just use binomial CDF. Second variance and then binomial binomial PDF. And then trials, there's going to be 20 probability of success. In this case, it's defectiveness. And the X value is just simply going to be exactly 1. Paste, bam, we have 0.2724. So about 27% chance this is going to happen. That exactly one of these toasters are defective. Define the random variable X, toasters or defective toasters, let's just say. So X counts for the number of defective toasters. Then find the mean and the standard deviation for X. Now for this, to find the mean and the standard deviation, what you can do is actually figure out probability of X equals 1, probability of X equals 2, probability of X equals 3, all the way down to probability of X equals 20. And then draw yourself a little table where X is simply 1, 2, 3, all the way down to 20. And then you can put them into the list and then probably get the mean and the standard deviation that way. Now, but who has the time for that? No one has time for that. So what we're going to do is we're going to see, is it normal? Because if it's normal, it's going to make it a lot easier for us to do, because the mean simply then becomes n times p. Standard deviation becomes square root of np times 1 minus p. This is the formula that you guys can use to if indeed it's normal and binary situation, you can use this formula to figure out the mean and the standard deviation. But the problem is, how can I assume the normality here? Well, there is another rule that I taught you which states that as long as np is greater than or equal to 10, n times 1 minus p is greater than or equal to 10, you can assume normality for that reason. So we have 20 toasters with 2% defectiveness. I believe that so 20 times the probability of that, 0.02. We want to consider no more than one of these things are toasters are defective. 2% of 20 is actually 4. No, actually 2% of that is 0.4, which is not less than or equal to 10, but 20 times 0.98 is indeed greater than or equal to 10 here. That might be a little bit of a problem, but we are going to use this. Otherwise, I'm not sure why they would say the normality has not been assumed in this particular case. But then find the mean and the standard deviation for X. I would actually, if I ever give you a question like this, because I can't assume normality, I would have to use this table format, but it's going to take it's too much of a time here. So in this video, obviously I can't show you that, but maybe if I could just do it on my own time and then just figure out the value of your mean and standard deviation will be very close to this thing anyhow. So we are going to figure out NP and N times 1 minus P. This certainly does fit in the large counts category, but this doesn't, so which bothers me at this point. But we're going to use these two formulas at the moment, and then we're just going to move on to the other things here. So N is 20, and the probability of success here is 0.02, I believe. Yes. So that is going to simply give me 0.4 for my mean of the expected. The mean for the X, the defective number of defective toasters here. And for the standard deviation, we're going to do 0.4 times 0.98, and we're going to just square root that value. So let me just go to my calculator here. So 0.4 times, what is it, 0.98, and then we could just square root that answer. So it's going to give me a standard deviation of 0.626, I believe. Define the random variable, but it doesn't meet the criteria to do this. So but the only way to actually do this problem is to solve it by just plugging into the formula here. So I really just have no other choice but to assume normality, even though it doesn't really meet the condition here. So I'm going to just put the C on the side because I really don't like the way that the answer key also said it. It needs to assume normality in order for you to be able to use that formula. Find the probability that at most two toasters are defective. So X is greater than or equal to 2. What that means will be then I will have to, at most, so that means X is less than or equal to 2. So that's probability of X equals 0 plus probability X equals 1 plus probability X equals 2. And so you don't want to find those individually, so you're going to use the CDF, right? So this is a CDF question. So I'm just going to go to my binomial CDF, and trials is 20, obviously. Probability is 0.02% effective, and X value is 2. And everything that's added up to that point is about 0.99. I'm going to just be a more specific 0.29 for that. And that should match up with the answer key there. Okay. All right. So now I'm going to go into 17. Draw a card from a standard deck of 52. Observe the card and replace the card within the deck. Count the number of times you draw a card under this banner. You observe a jack. Ooh, until. What does that mean, guys? Geometric random variable. So geometric random variable means you keep on doing it until something happens, right? So is a binomial distribution a reasonable probability model for the random variable X? State your reasons clearly, it says. Okay, so is a binomial distribution a reasonable probability model? No. Because this is geometric random variable. Why? Because it's going to be until. So if you see number 17 answer, X is not binomial because the number of trials is not fixed. It's got to satisfy the bins and it's not fixed. It doesn't tell you in this situation. Yes, the probability of Jack is 4 out of 52 and it's replaced. So the S, B, I, they all should make sense. But since it doesn't meet the standard criteria for N, therefore it's going to be geometric. Therefore, it's not a binomial. 18 and 19 give it whether it's going to be binomials or reasonable. Okay. So pool of potential jurors, 100%. So N is fixed. Each person in the pool is asked whether he or she opposes the death penalty. So yes or no, binary. X is the number who say yes. Okay, so that's the event that's going to be happening. Are each of these people independent of their opinions? Yes, you can also assume that. By doing the 0.1 and less than or equal to, or I'm sorry, less than the population. The sample, as long as it's less than 10% of the population, you can assume that it's going to be independent. The other one is same probability here. Each pool asks whether he or she opposes the death penalty. I believe 18 is still going to be the 4 conditions are satisfied for 18. Okay, so each person in the pool is asked whether he or she opposes the death penalty. So people who choose yes or people who choose no, the probability might be yes or no to X number of people say yes. So it's not like, okay, so it's not the fact that each of these people is going to choose half and half as if it was a probability. Each person in the pool is asked whether he or she opposes the death penalty. Okay, so I guess the reason why I say this was binomial is because they say all 4 conditions is satisfied. For this one, the probability of you choosing it, is it 50-50? Since there's only 2 choices, unless they told you that they don't have any political affiliation and they are guessing, I would have to disagree with the answer and say no for this one. But quite honestly, the probability cannot be 1/2 because this is you choosing a random resident is asked whether he or she opposes the death penalty. This is an opinion about death penalty, so it's got to be more biased. I don't know if it's going to be 1/2. Joey buys a Virginia lottery ticket every week. X number of times in a year, he wins a prize, it says. I think this is a typo because there's absolutely no information about the percentage of winning. I don't know that. X number of times in a year. What's the trial? I have no clue. This definitely got to be a typo. This has to be a no. I would assume 18 is a typo too, because you can't assume that these 2 people are gonna, like, the people are gonna vote for the 2 candidates half and half like this. That's simply not gonna happen. So they're gonna be both simply gonna be no for this one. All right, so fair coin is flipped 20 times. Determine the probability of the coin. Okay, so this is binomial situation, guys, right? 15 out of 20, like I said, that's your key to say it's going to be a binomial situation. So binomial PDF, because we're talking about probability X equals 15. So let's use the calculator here. Binomial PDF. Trials is 20, probability is 0.5, and this is 15. Paste, bam, that's going to be 0.014. So about 1.4% chance that that's going to happen. Find the probability that comes at least 15 times. That's more than or greater than or equal to 15. This means I have to do P minus 1 minus P. X is less than or equal to 14 because we have 15 as part of our probability, so we don't want to eliminate that. So when we do this, because the binomial PDF always counts for the binomial CDF, I'm sorry, they always count for the ones from the left. You want to go from 0 to 14 and subtract it away from 1 in order for you to get the rest of the probability. So you're doing it 20 times, and probability of success is 0.5. X value is 14. So it's 0.97. So 1 minus that answer, which should give you 0.02. Oh, what's going on here? Okay, so please tell me. Okay, good. All right, so with this, I know that this is going to be 1 minus 0.979. My final answer is 0.0206. So that's about 2.06% chance that's going to happen. And yes, that's the answer key. Find the mean and the standard deviation of the random variable of the coin flipping problem. Now this, you need to always assume the normality to do these types of questions, because in order for you to find the standard deviation, remember how we always did that? We put in a table. But we're not going to put all of these 20 values in a table. We always have to assume normality, and then we can use the formula for it, which states that the mean is NP. Standard deviation is square root of NP times 1 minus P. In order for assume normality, you have to have the normality checked by doing the large counts rule. NP greater than or equal to 10, N times 1 minus P is greater than or equal to 10. We're doing 20, 0.5 of that. Yes, that's about half of 20, which is greater than or equal to 10. So that checks. So 20 times, obviously, the probability of failure is also 0.5. So that also checks. They meet the conditions, the criteria. Therefore, you can assume normality, and then you can just plug into the formula here. So that's simply going to become 10. So the mean is 10. And the standard deviation is 10 times 0.5, which is 5. So square root of 5 here, which I believe it's going to be, so 2.26. 2.236. I just copied it from the answer key, but I can just show it to you guys here. 10 times 0.5. I mean, it's going to give you the same thing. 2.23606. Find the probability that x takes a value within 2 standard deviations away from the mean. You have to assume that 68, 95, and 99.7, the empirical rule stays in place. It's something we learned from chapter 2. 2 standard deviations from the mean means that it's the second value. So we can assume 95%. What we can do also is we can pull up our calculator here. And we can do second VARs. And we can do normal, I believe, CDF. So we have upper, lower, and upper bounds for all the probabilities. So 2 standard deviations away, we need to figure out that value, by calculations. 10, I don't think I can do calculations here. So 10 minus 2 times 2.236, 10 plus 2 times 2.236. Those are the 2 standard deviations away from 10. So it will be 5.528 and 14.4, 5.528. 14.0. What was the number? 14.4. Okay. Ooh, what's okay? Oh, I keep on forgetting the numbers. 5. Okay, 5.5, 14.4. I'm just gonna put that in and then see what happens. Mean, standard deviation. Okay, paste, bam. Okay, so it's about 95%. So empirical rule still stays because we're talking about a normal distribution. All right, so we're now on to 21 here. A headache remedy is said to be about 80% effective in curing headaches caused by simple nervous tension. All right, so define the random variable measured. It's going to be the number of headaches. What kind of distribution does the x have? This is binomial because percentage, S, 100 randomly selected, N. Independence is 100 less than 10% of all patients out there. So can we assume more than 1,000 patients out there? Yes. And B, headaches, no headaches. 2 things. Check. Calculate the mean, the standard deviation of X here. All right. So then what we have to do is we have to also assume that whether this is going to be normality or not. So assuming normality is for the large counts, NP greater than or equal to 10, NP greater than or equal to 10. And 1 minus P is greater than or equal to 10. So 100 times 80%, 100 times 20%. They're indeed both more than 10, so we can assume normality for this. So the mean is NP. The standard deviation is NP times the probability of failure, and you have to just square root that. So NP, we've already figured it out. It's 80, 0.8 times 100 with the standard deviation of 80 times 0.2. So it's about 16. So square root of 80 times 0.2. So it's 4. So we have a standard deviation of 4, and then we have a mean of 80. They should all check. Define the probability that x is within 1 standard deviation of the mean. That's 68% using the empirical rule, I believe. Use a normal approximation, find the area between these two. If you think about it with a normal distribution curve, mean is at 80. 1 standard deviation away from that would be 76. 2 standard deviations would be 72. You can do the same thing this way. So what happens is that 72 and 88, they're both numbers from the mean. You're moving 2 standard deviations away. So 2 standard deviations plus and minus from the mean. That means you can use the empirical rule and say that's 95% in total between those 2 values. Real resultant E should be close to the empirical values. Why is this true? Well, that's because you're moving 2 standard deviations away. Whoa. My pen is not working. Hopefully. Okay, so my Apple Pencil is at 0%. That's perfect. All right, so then we have 0. Yeah, so we have 95%. It should be close to the empirical rule because you're moving 2 standard deviations away. All right, so you can just write that down. I'm sure you guys can do that on your own. Number 22, recent study revealed that a brand new MP3 players may be repaired up to 3 times during its ownership. We have a probability distribution with the random variables 0, 1, 2, and 3. Compute and interpret the mean and the standard deviation of R. Please use the calculator. We're going to clear this list and we're going to clear that list. It's just really worthless values that we had from before. 0.4, 0.3, 0.2, 0.1. All right, so now we have all of this and stats, calc, you get the drill. Second, 2, second, 2, come on. Oh, God. Okay, second, 2, there we go, calculate. So the mean is 1 and standard deviation is 1. Oh, that's convenient. All right, so that is the answer key. So I think we're all good. Suppose we also randomly select a phone that may require repairs over its lifetime. The mean and standard deviation of the number of repairs for this phone are 2 and 1.2. So we are having phone and MP3 player. So we're combining 2 random variables together. Compute and interpret the mean and the standard deviation of the total number of repairs necessary for the 2 devices. All right, so the mean of the 2, you simply have to add them up. So it's 3. Standard deviation, 1 squared plus 1.2 squared. You guys already know how to do this. So I'm going to skip around a little bit. 2 squared. So 1.56 is my standard deviation with the mean of 3, I believe. Is that right? Yes, I did it correctly. Each MP3 players costs 15 and each phone repair costs 25. Compute the mean and standard deviation of the total amount you can expect to pay in repairs over the life of the devices. Okay. Total amount. Okay. So this is the probability distribution number of repairs necessary. All right. So that means that if this is the expected value of the total number of MP3 players as well as phones that's required to repair, but respectively speaking, there's 2 phones, so mu of X, mu of Y. Let's call these MP3 and let's call these phones. I know my expected value for MP3 repairs is 1 and phones is 2 as stated. And it says that it costs $15 per MP3, $25 per phones. So that is 15 plus $50, which should be $65 in total. Yes, and I believe that is the correct answer. So you just multiply the value of the number of expected number of repairs for MP3, multiply that by the cost, expected number of the phones that needs to be repaired, multiplied by the price, add them up because that's what the expected value combined random variables is all about, get 65. For standard deviations, remember that you have to make sure that you do 1 squared plus 1.2 squared. But not only that, those values needs to be multiplied by its respective price. So this is 15 times that, and 1.2 is the standard deviation, which you will multiply by 25. Remember, multiplying by the price or multiplying by anything impacts your standard deviation as well as the mean. So this is going to be your new value. Then I'm going to do square root of 15 squared plus 25 times 1.2 inside parentheses squared, so 33.54. That should be your standard deviation in terms of price of the phones and MP3 players. Number 23, Mr. Voss and Mr. Cole bowl every Tuesday night. Over the past few years, Mr. Voss scores normally distributed. Okay, awesome. Normally distributed with 230 and 40. Assuming the scores are independent, what is the probability that Mr. Voss scored higher than Mr. Cole on a randomly selected Tuesday night? Okay, so we're comparing the values in which what is the probability that Mr. Voss, so we're going to call V, greater than C here, so rather than Mr. Cole here. Okay, so what we want to do then, we have a normally distribution curve. Then if I actually assume that the probability of Okay, so this means that probability of V minus C is greater than 0, correct? So then what I want to do is I want to find out this by doing a, let's say, a normal distribution curve, but we also must be able to find out the mean of V minus C respectively, along with the standard deviation V minus C here. So to do that, it's just combining two random variables here, right? So we have a mean V minus C. So VOS is 212 and this is 230. So the mean of V minus C should be negative 18. The standard deviation is a little tricky, but remember, it's the same exact ordeal. 31 squared plus 40 squared, and then you have to add them up and square root them. So once I do that, 31 squared plus 40 squared, I get 50.6. So the standard deviation of this is 50.6. All right, so now I have the mean and the standard deviation of that respectively. What is the value in which I have to get that to be greater than 0? Because it says Mr. Voss scores higher means V minus C has to be greater than 0. So I go to second variance. This is going to be probability. So I'm going to actually do normal CDF. We have a mean of, well, we have a greater than 0, which means it should be 0, and upper boundary is anywhere between from 0 all the way of, let's say, 100, okay? Because upper boundary you don't really care about. If you draw the distribution curve, average is 18 and the standard deviation is 50. So if you actually move, it's got to actually be more than that. So standard deviation is actually quite high. So the mean is negative 18, standard deviation is 50.6. And when you do that, the probability actually of that happening is about 36%. So you use normal CDF and you can get this value because everything here, they said it was normally distributed. So you're combining the like terms in there with the formulas that I provided for you, and then you're getting the answer that way. Okay, so let's do some more multiple choice questions, and then we should be all good now. So binomial and geometric probability situations share many conditions. Identify the choice that is not shared. The answer to this question between, guys, geometric probability and binomial. Geometric means that it's until something happens. So you keep on rolling dice until you get a 6. Binomial, n is fixed. And this is n is not fixed. That is the main difference between the two. Okay, so the probability of success on each trial, we're not talking about the probability. There are only two outcomes. This is talking about B. This is talking about S. The focus of the problem is the number of success. Yes, we're talking about the number of trials. Success equals 1 minus the probability of failure. I mean, that's true for everything. The mean depends on the probability of a success. Yes, but that's not the main difference between geometric and binomial situations. It's always about the number of trials. Set up 10 cards consists of 3 red and 7 black. The cards are shuffled thoroughly and you turn cards over one at a time, beginning from top card. Let y be the number of cards you turn over until, again, geometric random variable here. The random variable y has which of the following probability distribution? So 10 cards, 3 cards, 7 black cards. One at a time, beginning with the top card, you keep on turning it over. So the problem with this is very similar to calling it a geometric random variable probably for this one. But the problem is, the unfortunate problem here is that the probability of each successful trial is going to be different. So you turn over one card, it's going to be, let's say, 3 out of 10. But let's say it's not and you move that card over. Now it's 3 out of 9 for the one that's on the bottom. And you keep on, the denominator number is constantly changing until you actually pick a card. It doesn't say the word with replacement. So therefore, even though it resembles a geometric distribution, it is not going to be a geometric distribution at all. The probability S doesn't actually meet the criteria. So it's not binomial. It doesn't say anything about normality. Even though if you want to assume normality, let's say by doing NP is greater than or equal to 10, look at the number of cards we have. I mean, obviously, if the N is already at 10, we're not in good shape. So because probability is always going to be less than 1, this condition will never meet up. So it's never going to be normal. Uniform distribution, no. The probability of this is not going to be uniform because the probability is always changing. So it's just going to be E for this one. Which of the following is a true statement? The binomial setting requires that there are only two possible outcomes for each trial, while the geometric setting permits more than 2 outcomes. That is not true because geometric also has P and 1 minus P. Geometric random variable takes on integer values from 0 to n. I think binomial also takes on integer values from 0 to 10, 0 to n. I'm just going to put a little side note on that one. If x is a geometric random variable and the probability of success is 0.85, and the probability distribution x will be skewed to the left, since 0.85 is closer to 1 than a 0. So what this means is that for geometric, if your probability of success is really high, that means that the chance of whatever that's going to happen in the very beginning, or if you were to, let's say, do this, you picking a card in the very beginning is actually quite higher than the one on the actual very end, because 0.85 means that you keep on doing this until you get the successful trial. Your chance of doing it on the first time around is 85%. Your chance of doing it on the second time around is gonna be less because you do it twice. That means you keep on having to multiply 0.85 or 0.15 times 0.85. That's the chance of you getting it on the second time around, I believe. Yeah, so that's the probability of geometric setting. So therefore, your probability is going to diminish by quite a bit. So it's going to look like this. This means it's skewed to the right, not skewed to the left. So C is absolutely not the correct answer here. An important difference between a binomial geometric random variable is that a fixed number of trials in a binomial setting and a number of trial varies. Okay, this is just that is just the perfect definition. The definition and the difference, the main difference between binomial versus geometric. The distribution of every binomial random variable is skewed to the right. No, that doesn't make any sense. It's not always. We always do not want to say everybody is skewed to the, like, that's simply just not true. To answer B, a geometric random variable takes on integer values from 0 to n. I believe the geometric random variable actually can start from x equals 1 to n. So you can say I'm trying from trial starting from 1 all the way to n, I believe. So therefore, this is not going to be the correct choice here. Number 27, a college basketball player makes 80% of her free throws. Composed probably is the same for each throw she attempts, and free throw attempts are independent. Probably she makes all of her first 4 free throws and then misses her 5th attempt in this season is, okay, so the probability that she makes all of her first 4 free throws, that means it's 0.8 raised to the 4th power. Then misses her 5th is 0.2. So there's really only one way to do that. So you're just going to put that in the calculator and then bam, you're done. Times 0.2, and I believe that's about this. So the answer to 27 should be B. Good. College basketball player makes 80%. It's the same. Free throws are independent. The expected number of free throws required until she makes her first free throw is, so that is a geometric setting. So that's a probability of success where the expected number of free throws required. Oh, the expected value is always 1 over p. That's the formula, right? So we're just going to do 1 over 0.8. That means it's going to be 10 out of 8, which is about this much. B. 28 should be B. Okay, so this is geometric. Suppose 40% of the cars in a town are white. A person stands at an intersection waiting for a white car. So you keep on standing there until you see a white car. So probability of x is less than 5 means that this is going to be a geometric CDF, which means it's going to be probability of x equal to 1 plus all the way down to probability of x is equal to a 4. So what I'm going to do is I'm going to go to my graphing calculator here, second there, scroll up. We're going to go to geometric CDF, guys. We're going to go from probability of 0.4. The x value is actually 4 in this case. So then it will be 0.87. I believe the answer for this one for 29, therefore should be D. The expected value of x, expected value of any geometric setting is 1 over p. So 1 divided by 0.4 should be 2.5, which is D for number 30. This one, 60% of the adults in a large town are registered Democrats. So a newspaper reporter wants to interview a local Democrat regarding, if a reporter asks adults on the street at random, what is the probability that he will find the Democrat by the time he has stopped 3 people? Which means I will do geometric CDF. until you do, so 0.6, and then you do 3, and then that's the correct answer, which is A. So I guess I misread this. So he will find a Democrat by the time he has stopped 3 people, means until you find third person, and then you have actually found a Democrat. Whether that's 1, 2, or 3, it doesn't matter. Wording could have been a lot different for this one. 32 on average, how many people will the reporter have to stop before he finds his first Democrat? So that's 1 over 0.6. Okay, that's not bad. So that's 1.67. That's not that bad either at all. All right, last page, finally. All right, so you are stuck at Vince Lombardi rest stop on New Jersey Turnpike with a dead battery. To get on the road again, you need to find someone with the jumper cables to connect. Suppose that 16% of drivers in New Jersey carry jumper cables. You begin to ask random people getting out of their cars if they have jumper cables. On average, how many people? So 1 over 0.16, right, guys? Always 1 over the probability to figure out the expected value of a geometric setting. So 1 over 0.16, 6.25. Bam. So that's D, 33. So you're going to give up and call a tow truck if you don't find a jumper cables by the time you've asked 10 people. What is the probability you end up calling a tow truck? Means that probability actually becomes by the time you've asked 10 people. So X has to be greater than 10, I believe. So that means it's going to be a geometric CDF. I'm sorry. I keep still saying PDF for some reason. So probability of success here is 0.16. X value here is 10. So when I calculate that, I get 0.8251. But remember, that is all the probability that is from 1 to 10. So you have to do 1 minus that value. So it should be about 17%, which should be B for this one. Great. Which of the following statements are true? The histogram of binomial distribution with 0.5 is always symmetric. The histogram of binomials is skewed to the right. The histogram of geometric distribution is always decreasing. That it really depends on the probability. So I'm going to eliminate everything with a 3 in it. So I'm really down to A or none of the above here. So the histogram with a binomial distribution with P is equal to 0.5 is always symmetric, it says. So what that means here, guys, is that if I have a binomial distribution of 0.5, that's your probability setting. And let's say, suppose you do 20, and then suppose you do, let's say you choose N, for example. Like, for example, right? It could be, quite honestly, be anything, but so let's say I do 20 coin tosses and I just do, let's say 0, then I do 21, and there's all these combinations. The vast majority of all of our successes and failures, okay, because of the way that the formula is structured, remember for binomial distribution, it's always NR, probability of R, 1 minus P to the power of N minus R. Now, if you think about it, the highest probability that you're going to get is in the middle for these types of things. So I'm going to show you an example. Like I'm flipping coins. I'm doing 50% heads, 50% tails. And let's say that I'm trying to figure out binomials PDF of trials 20, probability of 5, and X value of 0. So basically, I get 0 heads. Look at how low that probability is for 0 heads. Now, if I do the same thing, but if I do 1, it increases just by a little bit. You can see how that -5 is smaller than -7. That's the number of zeros in the front of it. So then let's say I change this to, let's say, a 5, much bigger. Then I change this to a middle, which is 10. Again, not much bigger, but slightly a bit higher than 0.14. Now, starting from here, it starts to go downhill because now, see, as soon as you hit the middle and you start to go down, or even close to being 20, let's say 15, your probability constantly goes down because you can't have all heads or all tails. Those are the least likely chances that that's going to happen. There's only one possible way in which those things can happen. You have all tails or all heads. So you're going to have a normal distribution curve when the probability, or not normal distribution, so you're going to have a symmetric distribution if your probability is 0.5. Okay, so the probability of that is really, really low. But then when I do this as 20, then the probability is very, very higher. So you do 19, obviously probability is a lot higher there. Then probability of 18, the probability of that is also higher. So what happens is you have a lot of high probabilities happening down here. And then the probability of these places are still very, 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 very low. So this is actually skewed to the left. So actually this one does have a typo because it says that it depends on the number of trials here. But the number of trials, it actually shouldn't make that much of a big difference, I believe. Okay, so you're doing this 190 times and it's going to make a huge difference here. Okay, so for this one, the distribution, I haven't really told you, but then it depends on the number of trials. But I know that for a fact that the one is always going to be true. I know the answer key says A, but technically only one should be true. Okay, so there are some iffy questions here, I have to admit, but you know, from what I see, most of these it should be fine. I mean, just use your calculator for most of these questions, and I think you should be okay. The rest of them, with the geometric variable setting, I think that was like the one that was really, really just one of those things that we didn't really practice a lot. And even if I give you that, just remember the formula for those. The expected value of that is always 1 over p. And for the standard deviation, please refer back to your notes. Standard deviation should be 1 minus p over p, like this. These are for your geometric variables. And remember, the main difference is that the trials is not fixed. Okay, all right. I think that should do for the video. Hope this helps. And I'll see you guys tomorrow.